Okay, now we're doing, this is part 2 of section 5.1, and I'm moving on to number 6. And number 6 is solve using the method of your choice. Okay, so to me, this looks like it would be really easy to use substitution. So I'm going to take the first equation, which is y equals 13 minus 3x, and substitute for y in the second equation. So I will get 3x plus, instead of y, you don't have to put parentheses, but I'm going to just to, so you can see where I put it in. 13 minus 3x equals 31. So I get 3x plus 13 minus 3x equals 31. Wait a minute. The 3x's go away. I get 13 equals 31. That is false. And remember, anytime you get something that's false, your variables disappeared and you get a false statement, that means there is no solution. And that's the way you say it in words. You can also say it using set notation, where you would put the empty set symbol. That literally means the solution set is empty. There is no answer to put into the solution set. Okay? So now let's try number 7. Okay, so let's see if you can see number 7 first. Okay, now same thing. Solve using the method of your choice. So this one, everything's lined up, so to me it looks like it would be very easy to use the elimination method. So I'm going to, remember, let's name them, equation 1 and equation 2. I'm going to multiply equation 1 times 3. 3 times equation 1 plus equation 2. And that will eliminate the x's, won't it? So 3 times equation 1 becomes, let's see, 27x minus 12y equals, don't forget the other side, 18. That's equation 1. Equation 2 remains the same. Negative 27x plus 12y equals negative 24. All of my variables subtract out, so I get 0 is equal to negative 6, which once again is false. So we know that this system has no solution. And remember, in class we discussed that the graphs of these two lines would then be parallel. They never cross. Okay. One more, number 8, solve using the method of your choice. I'm going to use substitution, and I'm going to start by solving for y in the first equation. So that will become y is equal to 7 minus 4x. Now I'm going to substitute that into the second equation. So I'll get 3 times, instead of y, I use 7 minus 4x equals 21 minus 12x. Okay? So I get 21 minus 12x equals 21 minus 12x. Hey, that's identical on both sides. That's called an identity. That is always true no matter what, because it's exactly the same. You can keep going if you want and add 12x to both sides, and you see that you get 21 equals 21, which is true. So that means this system has infinitely many solutions. But this is intermediate algebra, so you can't just write that. We want you to use the set notation. This is what you write. You draw your set brackets, and then the first part is the form that your answers are in. This stands for the set of all ordered pairs, x, y. Here's our big line, such that, that means the rule comes next, such that, and now you pick one of the original two equations. I'm going to pick the first one, 4x plus y equals 7. So in words, this is saying there are infinitely many answers, and all of them are the xy ordered pairs that are on this line. Because remember, the picture of this is that these, if you think about them as two different lines, one line is just drawn right over the top of the other one, or another way to think about it is it's really just the same line in two different forms. Okay? So those are the two strange cases that we can get. Now next, the truth is what we want to focus on now are the word problems. I'm going to let you guys do number 1. We actually did that in class. It's just kind of a thinking problem. You don't even need algebra to do it. So 9 was a warm-up. So let's start with number 10. Number 10 is some application stuff. So this is something you might see in a business math class or an econ class. So let's read 10. You invested $14,000 and started a business selling vases. Okay. Supplies cost $20 per vase, and you are selling each vase for $38. Determine the number of vases X. Hey, they just defined our variable for us. That must be produced and sold to break even. Okay, so you need some information to do this problem. First, this is a business type of problem, and what we need two functions. One is called the cost function. We use C for cost, and one is called the revenue function. We use R for revenue. So let's do those first. The cost function is how much it costs you to run this business. Well, first of all, it costs you the $14,400 that you invested, plus it costs you $20 per vase for every vase you make. So that would be 20x. Now the revenue is how much money you take in, not your profit, but how much you actually take into your cash register. Well, you're selling the vases for $38 a piece, so that would be 38x, 38 times the number of vases. The break-even point, there's two ways to think about it. The break-even point is when your cost equals your revenue. Another way of saying that is there's a third function that you'll see in business called the profit function. Profit is revenue minus cost. And your break-even point is when your profit is equal to 0. It's not positive and it's not negative. Okay, I'm just going to take my cost and set it equal to my revenue. So when my cost equals my revenue, then I know that I will be at the break-even point, and every vase I sell after that will make me some profit. Okay? I'll let you guys solve that. Don't forget to answer in a complete sentence, please. Please write, you must make and sell blah, blah, blah number of vases. I think it's 500 or something. Okay? Complete sentence. All right. Because I would like to do number 11, help you set up number 11. A rectangular lot whose perimeter is 500 feet. Okay, stop. A rectangular lot. I can draw a rectangle. There we go. Whose perimeter is 500 feet is fenced along 3 sides. Okay, now notice they say the whole perimeter is 500 feet. All right, so what I'm going to do is I'm going to label these length and width. Okay, and I will accept that as defining your variable if you label it on the picture. That's okay. Or you can define it in words, right? W equals width and L equals length. Okay, so I can write one equation right away, that the perimeter is 500 feet. So I know that 2 lengths plus 2 widths equals 500. Okay. Inexpensive fencing along the lot's length costs $18 per foot. Okay, so $18 per foot on the long side. Okay. And an inexpensive fencing along the 2 side widths costs only $7 per foot. So only $7 per foot along the 2 sides. The total cost of the fencing along the 3 sides comes to $4,100. Okay, I can now write another equation that has to do with the cost of the fencing. I know that 18 times L will tell me how much I spent for the expensive fence, plus 2 times 7 times W, see, because W is what the width is, 7 is how much it costs per foot, and I have got 2 of those sides, will equal $4,100. And now the question is, what are the lot's dimensions? That means what are the length and width? So now once again, there's your system, and it is your job to solve it and state your answer in a complete sentence.